Welcome to The Explainer. Today, we're going to tackle one of the most incredible procedures in all of modern medicine, the idea of completely rebooting a person's entire blood and immune system.
So, let's just jump right in with a massive question. How do you reboot a human body? I mean, what happens when the whole system that creates your blood just stops working? Can you really do a full-on factory reset? Well, the answer lies right here, with these amazing things called blood-forming stem cells. You can think of them as the master cells of your body. They're the fundamental building blocks that can become any kind of blood cell you need. Red cells to carry oxygen, white cells to fight infection, you name it. Okay, so first up, a factory reset for your blood. Let's talk about why you would ever need to do something this drastic in the first place. For people with diseases like leukemia or lymphoma, this procedure is, and this is no exaggeration, a total lifeline. Their bone marrow, which is basically the body's blood cell factory, is broken. So a transplant is designed to completely demolish that broken factory and then rebuild a brand new, healthy one from scratch. So where do these new master cells actually come from? Well, this is where it gets really interesting, because it's definitely not a one-size-fits-all kind of deal. There are basically two main paths you can take. First, you've got the autologous transplant, where you use your own healthy cells that were collected earlier. But we're going to focus on the second type, the allogeneic transplant. This is where you get cells from a donor, and that brings up a huge challenge. You have to find the perfect match. Now, for a donor transplant to actually work, the new cells have to be able to sneak past the body's security system, and that system is looking for these special genetic markers called HLAs. Think of it like a lock and key. The patient's body has all these unique locks, right? Well, the donor's cells need to have the exact right keys to get in without setting off any alarms. The hunt for this genetic twin always starts with close family. Brothers and sisters are your best bet. But here's the thing. For about 70% of patients, there's no match in the family. And that's when the search goes global, tapping into these massive registries with millions of volunteer donors, all in the hopes of finding that one perfect stranger who could be halfway around the world. So let's talk about the journey itself. It's a really intense process, but it's broken down into 5 very clear stages. And here's the roadmap for the whole thing. It kicks off with a bunch of tests. Then you have the harvesting of the cells, followed by conditioning, that's preparing the patient's body. Then comes the actual transplant, and finally, the long road to recovery. So let's walk through each one. All right, stage 1 is all about getting ready. Before anything major happens, the medical team runs a whole battery of tests. They check everything, heart, lungs, kidneys, making absolutely sure the patient is strong enough to handle what's coming. Stage 2 is harvesting. This is where they collect those life-saving stem cells from the donor. Now, the most common way to do this today is actually non-surgical. The donor gets some shots that boost their stem cell count, then their blood just gets filtered through a machine. The older method involved surgery to pull marrow right from the hip bone, but that's less common now. Stage 3, conditioning, is easily the toughest part. This is the real factory reset. The patient gets hit with incredibly high-dose chemotherapy or radiation to completely wipe out their diseased bone marrow. It is a total demolition, clearing the way for the new cells and making sure the old immune system is too weak to fight them off. So after all that intensity, you'd think the transplant itself would be complicated, but stage 4 is surprisingly straightforward. On what they call day 0, the donor's stem cells are just given to the patient through an IV, almost exactly like a blood transfusion. And the truly amazing part? The cells just know where to go. They travel through the bloodstream and find their way home to the bone marrow all on their own. And finally, we get to stage 5, recovery. And really, this is just a waiting game. But it's an incredibly high-stakes one. The patient's immune system is gone. I mean, completely zeroed out. So they have to be in total isolation. For weeks, everybody just waits and watches for that one critical sign, that the new stem cells have engrafted, that they've settled in and are finally starting to build a brand new immune system. Now, of course, a procedure this powerful doesn't come without some major risks, and they are just as serious as the potential rewards. The biggest single risk is a condition called graft versus host disease, or GVHD, and it's kind of the ultimate irony. It's the total opposite of a typical organ rejection. In this case, it's the new immune system, the graft, that sees the patient's entire body, the host, as foreign, and it starts to attack, which can cause some serious damage. And beyond GVHD, that long road to recovery has plenty of other bumps. With a brand new but still very weak immune system, the risk of getting a serious infection is incredibly high for a long time. Not to mention that intense conditioning treatment has its own side effects, nausea, fatigue, and can even have long-term impacts like infertility.
You know, the success of this entire thing for thousands and thousands of people really depends on the kindness of complete strangers. And that brings us to our final and maybe most important point. So, what does it actually take to be a part of this incredible life-saving network? Who can do this?
You might be surprised by how simple the basic requirements are. If you're generally healthy between the ages of 18 and 50 and weigh over about 45 kilos, chances are you're eligible to get on a donor registry.
And the process to join is unbelievably easy, usually just a simple cheek swab kit that they mail right to your house. Now, it's really important to get this. You are not committing to donate just by signing up. You are simply adding your unique genetic type to a global database. You're just raising your hand and saying, hey, if I'm the one person in the world who can save this other person, give me a call.
And that's a really powerful idea to end on, isn't it? That a simple swab of your cheek could mean that one day you might be the one and only hope for someone out there who's waiting for a second chance at life.